Okay, so we're going to go through the quadrilaterals review and try to talk you guys through this, kind of explain a few things. So first, number one, which statement is true about every parallelogram? I mean, you can always draw your parallelogram. Okay, all four sides are congruent. Well, we know that's not true because that's what a parallelogram looks like. The interior angles are all congruent. Well, this angle is clearly not the same size as this one. Two pairs of opposite sides are congruent. Well, that's true. The diagonals are perpendicular. That's actually not going to be true. And things to remind you of all four sides, that's actually going to be a rhombus and a square. All interior angles, that's going to be a rectangle and a square. Diagonals are perpendicular. That's going to be a rhombus, a square, and a kite. Okay, so the answer was C. Which statement is not always true about a parallelogram? So we're looking at not. So just be careful about on the test. So the diagonals are congruent. Which statement is not always true about a parallelogram? Diagonals are congruent. That is not always true. The opposite angles are congruent. That's always true. Opposite sides are parallel. That's the definition. Opposite sides congruent. That is also always true. So the answer was A for that one. Number three, in an isosceles trapezoid. Okay, so we'll draw this out. So we have an isosceles trapezoid, which means that we have two sides congruent to each other. And then we're going to mark A, B, C, D. It says AB is congruent to CD. If BC is equal to 20 and AD is equal to 36, and AB is equal to 17, what's the length of the altitude? Okay, so the first thing that you need to do with this is you need to draw in the altitude. Okay, so that right there. Because that's the height of your trapezoid. I drew it there because, well, actually, you'll see, if I draw in two altitudes, you guys see that there's a right triangle there and a right triangle there. And although you might not know a lot about trapezoids, you guys do know a lot about right triangles. So the thing about it with right triangles, right now I don't have enough information. I only have two pieces of information. I need three to solve parts of a right triangle. So I need another side or an angle. I don't know anything about the angles, but if I could find this side, then I could use Pythagorean theorem to solve. So what I look here is if from here to here is 20, then this is also going to be 20, which means that this distance here, so this distance here and here, well, 36 minus 20 is 16. So those two parts, this part here and this part here, must add to be 16. And I know it's an isosceles trapezoid, so each part must be 8. Okay, and so I just use Pythagorean theorem. Leg squared, I say that my altitude is x, so it's going to be x squared plus 8 squared is equal to 17 squared. I do my 64, 17 squared. Okay, so this is x squared plus 64 squared equals 289, or 64 squared to 64. X squared is equal to 225. Take the square root of each part, and the answer is C, 15. Number 4, which statement about quadrilaterals is true? So quadrilaterals have 4 right angles. Well, no, that's only true if it is a square or a rectangle. All quadrilaterals have 4 sides. That's the only part of the definition. Have equal sides. Well, that's only going to be if it's a square or a rhombus. And all quadrilaterals are parallelograms. Well, those are only parallelograms, but you have trapezoids and kites that are not parallelograms, plus regular quadrilaterals that have no special properties. So the answer was C. Okay. Next one, which statement is false? All parallelograms are quadrilaterals. That is definitely true. Okay, they all have 4 sides, so that's why it's important to know your definitions. All squares are rhombuses. That is true. If you guys remember your chart, all squares are rhombuses because they have 4 congruent sides. All rectangles are parallelograms. That's true. All rectangles are squares. Okay, this is actually not always true. The only time a rectangle is a square is if it has 4 congruent sides. So this is going to be D. Number 6, in parallelogram L, M, N, P. Okay, so we draw it out. That's going to be important. So make sure that you write the letters L, then M, then N, then P. Just make sure that they're clockwise, so on and so forth, or counterclockwise. As long as they're in the same order, you'll get the right answer. So L, M, N, P, or L, N, P, M. Okay, they intersect at point Q. If NLP, so this angle right here is 25 degrees, and LPN, so that's going to be this big angle right here, is 85 degrees. Okay, and remember, my diagram's not accurate. It says find MLN, which is this angle right there. Okay, so one of the things that I know is that this whole angle right here has to be 180 minus 85 degrees, so it has to be 95 degrees, because these two angles are supplementary because it's a property of a parallelogram. Okay, so that's 95. That little red part is 25, so it's going to be 95 minus 25. 95 minus 25, which is 70 degrees, so C. Okay. Consecutive angles of a parallelogram, so you look at that right here. You know that they're supplementary, so they add to be 180 degrees. The ratio is 5 to 4, so 5 times some number plus 4 times some number is going to be equal to 180, because that's a simplified form. You have 9x is equal to 180. X is going to be 20. 20 is not my answer though, because we pay attention. It's asking you what the obtuse angle is. So we have an angle that's 5 times 20 or 4 times 20. The one that's 5 times 20 is going to be the obtuse angle. So that's going to be 100 degrees, which is also C. Alrighty, so that's the first page. Choose the statements that must be true for a rhombus. Hopefully you know how to draw a rhombus, because that could actually be helpful. So you know that a rhombus kind of looks like this, okay, roughly. Okay, the diagonals are congruent to each other. So is this distance the same as this distance? No. This is going to be, from here to here is shorter. That's, if they were congruent, then it would be a square. So this is actually going to be false. Okay, the diagonals bisect each other. Well, since it's a parallelogram, this is actually a property of a parallelogram. Okay, so that's going to be true. Diagonals are perpendicular. Actually, we know that this side is congruent to this side. This diagonal is this diagonal is congruent to itself. This part is congruent to this part. So for this figure, these two angles are congruent to each other. So you could do a proof where you could just memorize it. This is actually true. And diagonals bisect opposite angles. So I can actually prove that, well, since this triangle and this triangle are congruent to each other, that angle and that angle are congruent to each other. So that is also going to be true. Diagonals bisect opposite angles in both a rhombus and a square, and one pair in a kite, just to remind you. Cross section of an attic, the shape of an isosceles trapezoid shown in the accompanying figure. Height of the attic is 9 feet, BC is 12. So this is something very similar to the third problem. So I kind of draw this in. I know this is going to be 9 feet. This distance right here is 12 feet. Since this is an isosceles trapezoid, those are congruent to each other. So what we do look at is this right here. These two distances are going to be 28 minus 12, which is 16. And then I know that, well, this distance is the same as this distance. I know that I add to 16, so this is going to be 8, and this side is going to be 8. What you see is you have your right triangle here. You know, leg squared plus leg squared equals, I'm going to call this x, hypotenuse squared. So you square all that, or square and add it. 145 is equal to x squared. X is equal to radical 145. It says to the nearest foot, so that means you put it in your calculator versus simplest radical form, and you get 12 point something. So it rounds to be 12 feet. Number 13. So number 13, everything is kind of nicely marked in the diagram. Things to remember about a rhombus, you know that all of the sides are congruent to each other, so that's helpful because it's a parallelogram. Diagonals bisect each other, so those are congruent to each other. Diagonals are perpendicular, so I know that these are all right angles. And then we also know that diagonals bisect opposite angles, or at least you should know that. Hopefully you'll remember that for the test. So these are congruent to each other. Okay, so now the challenge is trying to figure out what properties we're going to use, because we're trying to find SR, RT, and TAS. So essentially what we're going to have to do is we're going to have to find the values of X, Y, and Z. Now I see Z in two places. I see Z here, Z here, or 3 places. There's no relationship between here and here because the diagonals aren't congruent to each other, but I do know that 3Z is equal to 4Z minus 8 because the diagonals bisect each other. That will actually help us find RT, because then if I can find Z, I can replace this Z with whatever value I find there, and then from there we can substitute it and double it. So for this, I'm going to subtract 4Z, subtract 4Z. This ends up being negative 1Z is equal to negative 8. And so Z was equal to 8. Once I knew Z was equal to 8, I can do 5 times 8 plus 5. That's going to be 45. That would be the length of ET. I want RT. Well, if this part is 45, then the other part also has to be 45. So the distance from R to T would have to be equal to 90 to start. Okay, so that's our first one. The next one is SR. SR is this distance here. I know that all of the sides are congruent to each other, so I know 8x minus 5 is equal to 3x plus 30. Okay, so 8x minus 5 is equal to 3x plus 30. I subtract 3x, subtract 3x. 5x minus 5 equals 30. Add 5, add 5. 5x equals 35, divide by 5, divide by 5. X is equal to 7. So I know x is equal to 7. I'll complete this problem because it says I want to find this distance right here. So this is going to be 8 times 7 minus 5, which is 51. So I know the distance from S to R is equal to 51. Okay, and then the last one. So this is a little bit trickier. These angles, this angle here and this angle here, because we want to find TAS, are not congruent to each other. But we do know that this angle, and this angle do add up to 180 degrees. So we know 5y minus 2 plus 9y plus 8 plus 90 is equal to 180. So this is relying that you know the properties, okay? And then you just find the sum of the interior angles. So this is going to be 14y plus 96 is equal to 180. 14y is equal to 84 when I subtract. So y was equal to 6. Now it's asking for TAS, so it's going to be 9 times 6 plus 8, which is 62 degrees. So the measure of angle TAS is equal to 62 degrees. Okay, so that was just using the properties, and you see that I started the problem map by doing the properties. Okay, quadrilateral has 4 congruent angles. It is a rectangle. To start off with, this is actually always true. The reason why is all squares are rectangles. It can be a specific type of rectangle, but since a square is a type of rectangle, that is true. If consecutive angles of quadrilateral are supplementary, then the quadrilateral is a rectangle. That's only sometimes true because that's also true for, this is going to be also true for a rhombus, but which is not always, or the only time a rhombus is a rectangle is when it's a square. It's also true for a regular parallelogram. The other thing I don't like is that it doesn't specify. Uniconsecutive angles are supplementary also in a trapezoid. It has 2 pairs, not 4 pairs. The diagonals of a rectangle bisect each other. That is always true because a rectangle is a type of parallelogram, so this is always true for parallelograms. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a rectangle. That is also only sometimes true because it could be a rhombus or a regular parallelogram. So, number 12, determine whether each sentence is always, sometimes, or never. Consecutive angles are complementary. If I were to ask you hint, hint, wink, wink, nod, nod, we'd actually change this to supplementary to make it actually true, but this is actually never true. It would have to be supplementary for it to be always true. Consecutive angles of a rectangle are congruent. That is always true. The diagonals of a quadrilateral are congruent. The quadrilateral is a rectangle. That is only sometimes true because you also have an isosceles trapezoid. Okay, and so a diagonal of a rectangle bisects 2 of its angles. Didn't really love this question because it's either going to bisect all 4 because all the angles are the same, or only. I'm going to say this is a never true statement unless it is a square. And then that would be, instead of 2 angles, that would actually have to be all 4. Okay, because a square, diagonals are congruent. It also bisects opposite angles because it's also a type of rhombus. They all happen to be the same. So it's only true for a square. Number 8, find the perimeter of the kite. Okay, so what do I know about kites? I know that one diagonal bisects the other diagonal. I also know that the diagonals are perpendicular to each other. That's actually really helpful because even though we don't have any of the sides of this kite, we can find the sides. Ooh, that was fun. That's kind of neat. Okay, we have these sides of this kite. We actually need this side here, this side here, this side here, and this side here. We can use Pythagorean theorem. So if this part right here is 6, this is 6 because one diagonal bisects the other. So I can use Pythagorean theorem to find these 2 sides, which happen to be congruent to each other. So that's going to be 3 squared plus 6 squared is equal to, I'll call this x, and I'll call these sides y. So it's going to be equal to x squared. 3 squared is 9, 6 squared is 36, is equal to x squared. 45 is equal to x squared. X is going to be radical 45. I'm going to simplify 45 over here. You can't divide 45 by 2, you can divide it by 3. That's going to be 15. 3 times 5, and 5 times 1. So we have a pair of 3's out. So it's going to be 3 on the outside because that's the part that I can take the square root of, and we have a 5 on the inside. So that's my x. For my y, I have a 6 and a 12. So I'm going to do 6 squared plus 12 squared is equal to y squared. That's going to be 36 plus 144 is equal to y squared. 180 is equal to y squared. Y is equal to radical 180. We do our simplification of 180 over here. 180 divided by 2 is 90. 90 divided by 2 is 45. 45 divided by 3 is 15. 15 divided by 3 is 5. 5 divided by 5 is 1. And when I'm factoring this way, I always end with 1 right there. So I have a pair of 2's and a pair of 3's. So on the outside, 2 times 3 is 6, radical 5, and that's side y. Now it's asking to find the perimeter. You find the perimeter, you add up all the sides. So this is going to be 3 radical 5's plus 3 radical 5's plus 6 radical 5's plus 6 radical 5's. Now when you are finding the perimeter, you just add the coefficients. Okay, because it's a quantity of something. It's like 3 bananas, 3 bananas, 6 bananas, and 6 bananas. That's going to be 3, 6, 12, 18. So that would be 18 bananas, or in this case, 18 radical 5. So all I did was add the front numbers, and so the answer to that one is A. In a certain quadrilateral, 2 opposite sides are parallel, and the other 2 opposite sides are not congruent. So 2 opposite sides are parallel. So if it's just 2 sides being parallel, then it's going to be a trapezoid, and the other 2 opposite sides are not congruent. Okay, so this would be something like this, where these would be parallel, but this and this would not be congruent to each other. So that had to be a trapezoid. For the next one, okay, AC and BD intersect each other. Triangle ABC is congruent to DCB. If that's true, by CPCTC, I know those 2 sides are congruent. I know these angles are congruent. This angle is congruent to this angle because those triangles are congruent. So which statement is true? AC is congruent to BC. That's not necessarily true. And then we have CDE. Okay, so CDE, which is this angle here, is congruent to BA, BAD, which would be the whole angle, so that's not going to be true. CD is congruent to AD. Well, we know that CD is congruent to AB, so that's not true. So by default, it's going to be D. And if you see CDB and BAC, they're both marked. So that was that one. Number 16, in parallelogram ABCD, AC and BD intersect at point P. So first thing we need to do is draw our parallelogram. Okay, I write my letters in order, A, B, C, D. AC and BD intersect at point P. AP is 4y. BP is 3y plus 4. CP is 2/3 x. And dp is equal to x. Now, first thing we have to think about is, what do I know about parallelograms? Well, I'm being given a lot of information about the diagonals, and the one thing I know about the diagonals is that they bisect each other. So I know that AP is going to be equal to PC, and I also know BP is going to be equal to PD. Okay, so if that's true, then I know that 3y plus 4 is equal to 2/3 x, which isn't quite helpful because I have 2 different variables. The other thing that I know is true is that, oh geez Louise, no, I got it. Actually, I set this up wrong, sorry about that, guys. It's going to be 3y plus 4 is equal to x, there we go, because this part is congruent to this part, sorry. And then I also know that 4y is equal to 2/3 x. Okay. So by themselves, I can't solve, but I know that x is equal to 3y plus 4. So what I'm going to do is I'm going to replace this x with 3y plus 4. So this is going to be 4y is equal to 2/3 times, and then instead of x, I'm going to write 3y plus 4, actually, like that. Okay, I do distributive property. This is going to be 4y is equal to, if you distribute here, you end up with, this is 3 over 1. This is going to be 6 over 3y plus 8 over 3. Okay, you have calculators, so you can do that. If you want to clear your fractions, you can actually multiply each side of this by 3. So this is 12y is equal to, well, these fractions were cleared out, 6y plus 8. Subtract 6y, subtract 6y. I have 6y is equal to 8, divide by 6, divide by 6. Y is equal to 8, 6, or it could also be equal to, because we could write it out, could also be equal to 4/3. So I know my y value is 4/3. Once I know my y value, I can actually plug 4/3 in to find my x value. So I'm actually going to replace this y with 4/3. So this is going to be 3 times 4/3 plus 4 is equal to x. These actually divide out. I have 4 plus 4 is equal to x. 8 is equal to x. So the key to this is actually solving for a variable and substituting into the other equation, systems of equations. Okay, so we have everything there. All right, so first off it says find the measure of, so it's a parallelogram. I know that opposite sides are parallel. Okay, it says find FJH, which would be this whole angle here. Well, to find this whole angle there, I remember that these two angles are supplementary, so they add to be 180. So this is just going to be 180 minus 68, which is 112 degrees. Next thing is it says find JF. Well, I know opposite sides are congruent in any parallelogram. That's a property, so that's 19. JFG, well, that's this angle. Opposite angles are, actually, I should put that there, are congruent to each other, so this also would have to be 68 degrees. And it says find FG, same reasoning, opposite sides are congruent, so FG would also have to be 34, and we don't have any units there, so we don't have to worry about that. Okay, number 18 in the accompanying diagram. This one's actually pretty, we've kind of already looked at this. We just have to be careful with solving because it's asking for the measure of b. The first thing I have to find is x. So we have 2x plus 10 is equal to 3x, subtract 2x, subtract 2x. And so we have my x value is equal to 10. And then knowing that, this is just going to be, it says find the measure of 2x plus 10. Oh, geez, Louise. I said they add to 180, and then I set them equal to each other. Let me try this again. 2x plus 10 plus 3x is equal to 180. There we go. So I apologize for that. 5x plus 10 equals 180. 5x is equal to 170. X is equal to 34. This is going to be 3 times 34, which is 102 degrees. So the measure of angle B is equal to 102. So sorry about that. Should have thought through that a little bit more. Okay, so we have to prove that it is a parallelogram, but it's not a rhombus or a rectangle. Now you can graph this, which is fine, but the first thing I want to do with all of these is actually find the slope of each side. So I want to know the slope from A to B. I want to know the slope from B to C, from C to D, and from A to D. And that'll actually show a few things. First of all, I want to show that the opposite sides were parallel. So that would be the first thing. And then for it to not, and then the slope will also tell us it's not a rectangle, because if the slopes aren't opposite reciprocals. So the distance, so from A to B, it's your change in y. So it's y2 minus y1 over x2 minus x1. So from A to B is going to be 6 minus 6 over negative 5 minus 6, which is 0 over negative 11, which is going to be 0. So the slope of the first one is 0. B to C is going to be 6 minus negative 3 over 6 minus 8. So that's going to be 9 over negative 2, which they are not the same, so, or they're not opposite reciprocals, so I already know are not perpendicular, so not a rectangle. I keep going from C to D, so I do my change in y, negative 3 minus negative 3, over my change in x, which is 8 minus negative 3. That's going to be 0 over 11, which is still 0. So I know that these two sides are parallel. A to D, so this is going to be 6 minus negative 3. Okay, over negative 5 minus negative 3. Again, we have 9 over negative 2, which also shows that these two sides are parallel. So we know opposite sides are parallel. Okay, because they have the same slope. Okay, so the last thing we have to do is we have to prove that it is a rhombus. And as far as a rhombus goes, you actually only have to show that two sides, two consecutive sides, are congruent to each other. Because then if two consecutive sides are congruent to each other, then since opposite sides are congruent to each other, it must be, then the rest of the sides must be congruent. So for the next thing, we're going to do distance formula. So I'm going to just do the distance from A to B. Actually, this would just be the slope A to B, and I'm going to do the distance from B to C. And so the distance from A to B also happens to be, I'm going to tell you that the distance from A to B, when I subtract my x's, is going to be, and if you guys remember, your slope will tell you that. My distance between my x's is going to be 11, negative 11. My distance between my y's is 0. But we'll just do this. So it's going to be negative 5 minus 6 squared plus 6 minus 6 squared. So that's going to be negative 11 squared plus 0 squared, which is the square root of 121, which is just plain old 11. Okay. And then from B to C, we do the same thing. You can actually kind of cheat by looking at these values here. So I know it's going to be 6 minus 8 squared plus 6 minus negative 3 squared. That's going to be negative 2 squared plus 9 squared, which is radical 85. These are not the same. So sides are not congruent, so not a rhombus. And you're done there. So the key is, of course, slope and then distance formula. I'm going to write the distance formula out for you. X2 minus x1 squared plus y2 minus y1 squared. And so that's going to be your two formulas for that. Okay. Sorry about that. And our last one is a proof for that it's a parallelogram. Ooh, good Lord. Alrighty. So here we go. We're back to this. So it says, so we go through. Okay. We go through, we write our givens. So it says JKLM is a parallelogram. That's given to us. We know JM is congruent to LN. That is also given to us. I'm actually going to mark that in my diagram. So it's JM is congruent to LN. And the other thing that is given to us is angle LMN is congruent to angle LNM, which is this angle and this angle are congruent to each other. Okay, so that is also true. What's interesting there is if I know that these two angles are congruent to each other, then I know LN must be congruent to LM, okay? And that's because of base angles theorem or converse, which just basically says if two angles are congruent, then the opposite sides are congruent, okay? So let's just keep going. So then we also know by transitive property that if Ln and Lm are congruent, then Jm, or by substitution, Jm must also be congruent to Lm. Okay, that's by substitution. Okay, because if Jm is congruent to Ln is congruent to Lm, then Jm must be congruent to Lm. And so that we have two sides congruent, we have to show that all four sides are congruent to each other. Well, because JKLM is a parallelogram, we know that JM is also congruent to KL, definition of a parallelogram. And we also know that JK must be congruent to LM, also definition of a parallelogram. So in here, I do have all four sides. You can actually stop there and say, okay, I've proven that all four sides are congruent to each other, definition of a rhombus. If you do want to write it out, I know that JM is congruent to LM. So I know JM is congruent to LM. LM is congruent to JK. And Jm is congruent to KL by substitution. So then I know that our figure JKLM is a rhombus. Definition of a rhombus, because you've proven all four sides. Skip the last proof. It's a little much. We really haven't done a lot of this stuff here, but that's it for